Hi, this is Richard from pi3dscan.com. I thought I would make an instruction video on how to take a full body 3D scan and process that with Agisoft in such a way that you can automate the creation of the bounding box in such a way that the bounding box is leveled with the ground and that you have an accurate coordinate system. Now this is easy for and later on cleaning your model, that you can easily cut out the floor. But it's also important if you want to take your scan, for instance, into a gaming engine like a Unity or a Mixamo. It's important then that the coordinate system is correct according to what the gaming engine is requiring. And in most gaming engines, they require the y-axis to be up. So within Agisoft Professional, this is fairly easy to do with markers. Here you see an overview of my scanner with my doll in it, and we've created a floor mat with markers on it, and they are with a fixed distance. The wide distance between the markers is 70 centimeters, and the short distance between these markers are 40 centimeters. In the end, we need to make sure that we scan and we capture at least 3 markers, a corner marker and an X marker and a Y marker. Now besides that, we also have in our scanner on each side in the middle 2 marker plates, and this allows us to dictate what the middle of the scanner actually is. So we'll be using 2 markers from the right side and 2 markers from the left side, and by taking their average in coordinates, it gives us the middle point here. That together with the 3 markers on the ground allows us to fully automatically do the ground planing of the model. So let's get started. Let me actually take my images and show you how we actually process this model. So I'll first, of course, add my photos into this model, and we'll take the model here. And I first always start off with taking actually the image set without the projection. So this is my model where I'll have no projection yet on the model. As you can see, if I look at the photo, there's no projection here. Now the first thing I want to do now is actually on these images start detecting the markers. The reason I am actually doing this on the set without the projection is that I found that if you take the image sets with the projection can interfere with the software detecting the markers, and then you actually get less markers detected. So we're using here right now the image set without the projection to get the best result in detecting our markers. Now after this is done, shouldn't take too long. There we go. We now actually have our markers, and we can actually, if we go see this here, you can see actually that there are markers identified. The second thing that we want to do is actually place a mask on our photos. Let me just put it here. The way in how we mask our photos is by actually also taking a scan of the images with the scanner empty. If you have a scan of your scanner that's empty plus a scan where you of course have the person in the scanner, you can just click any of these images. You can right click and you can say import masks. And by importing masks, we're going to say from background, make sure that you're using the right file name of the files that you'll be providing. In my case here, the file names of the empty scan will be identically the same as the file names of the scanner with the actual person, in this case the doll in it. They're just coming out of a different directory. So for my case it is file name. So that's the original file name, .jpg. I'll select to apply this to all images, and let me actually just turn this on so you actually start seeing what's happening. Is I'll do import mask from background, apply to all cameras, and now I actually select the empty scanner without the projection as well. You see, I'll just select the folder, you don't see any files in here, and now it actually starts to go to work. And what it's actually doing, it is comparing the image sets of the scanner being empty and the image sets of the scanner having the doll inside of it, and it automatically creates a mask. Now this is nice in Agisoft that it allows you to give cleaner results, but also importantly it will only process the white data. It has to therefore process a lot less data, and therefore the rendering time actually will be faster to create a dense cloud model and a mesh and all those kinds of things. So let's run through this, and then we'll take it on from there. So now we have automatically created a mask of our images. As you can see now, we have a clean mask of every single image. before we actually want to start processing and start aligning the cameras, we want to make sure that we are using the image sets of where the actual image actually has projection on it. And in this case, as you can see, that's not the case yet. So to change this, it's very simple in Agisoft. You just click any random image, you right click on it, and let me just, so that you can see it, you click any image, you right click on it, and you select change path. And by changing path, I can actually now go to the path of my doll with projection, which is in my case the _2 directory. I'll select the image and I'll say apply to all cameras. What Agisoft now will do is actually it will automatically swap out the images to the images in the new directory. Now any images that I will click, you will see that these are images actually that have projection on them, so very easily. The great thing is that it did not delete anything from the mask, so the masking data is still there, just the image itself has been replaced of the image with projection. So now that we actually have the right images with projection, we have the mask created, we have our markers detected, we can now start our normal workflow. We can align our images, and I'll align my images, importantly to make sure that you have constrained feature by mask, so this will tell it to only start doing the math on the white areas, not on the dark areas. And it will of course start aligning the cameras and gives us a sparse cloud. So let's get this going. So it has now aligned the camera, so let's actually see where this ends up with. If we now actually look at the model, we see that we have our model, and we see that by definition typically the bounding box, well, it just gets randomly placed. In this case it's definitely somewhere crooked, it's definitely not flatly orientated to the bottom. So as I said, how the script actually works to actually correct this is actually fairly easy. We need to be able to see 3 corners of the floor bounding box, and that could be 3, 1, and 2, or 3, 4, and 2, as long as it's an L shape that we have the 3 coordinates. And we need to get 2 coordinates from each side. So in this case here, I can use, for instance, the upper 2 markers, marker 21 and marker 22, and I actually have marker 6 and marker 7. So let me actually show you the actual script that I'll be running. So how the concept works is you have to specify what your which marker is your corner point, which marker actually has the distance over the x-axis, and which marker has the marker over the p-axis. So in my case here, I am taking marker 1 as the corner, and I'm using marker 3 as the depth going on the y-axis, and I'm marker 2 as my x-axis. And as the floor mat that I have is calibrated, I made it into an A1 poster, and I set the distance between the long distance to 70 centimeters and the short distance to we don't need this here. The short distance to 40 centimeters. Now, besides specifying these 4 markers, I also need to specify my 4 corner markers, and I'll clean up my script to make sure that actually this will be a little bit easier to do. But here I'm specifying marker 21, 22, 6, and 7, and it's just going to use this to calibrate, to calculate the average of these coordinates, which gives us the middle point of our scanner. The only other thing that I can actually specify is the dimensions of the box that I'm actually going to create. So based on the middle point, what the height of the box is going to be, what the depth of the box is going to be, and what the width of the box is going to be. So let me actually run this script for you. So if I actually, let's see, get my console out, I'll run the script, and you will now see that if I look at any orientation, I'll get a very correct orientated model with the bounding box in the middle. And if you look at my X, Y, Z, my Y is up, my Z is to the right, and my Z is towards me. And that's what I need for programs like Mixamo. Now, if I find that the box is too big or too thin or too deep or too narrow, I can very easily just change the script. And I can say, for instance, well, I don't want the box to be 1 meter width. I want the box to be just 50 centimeters width or something like that. And now if I will rerun the script, you'll see that my box is just 50 centimeters. Now my doll is not that slim, so I do actually need to make it a little bit wider. for me. So let's take 80 centimeters. There you go. I'll rerun the script. Now the only thing that you want to probably tune for your own scanner is the height of the box. The height of the box instead is measured based on the middle point, and then of course going half of it going down and half of it going up. And what you want to do is you want to make sure that that middle point, the calculation just gives you the points directly above the feet, so that we're cutting out the floor in Agisoft, so we have to do very little labor on it. I think in my case I've already tweaked this a bit, so I think I should be set up. I've specified my box to be 2 meter and 23.5 centimeters in height, and that for me gives me just a good cut straight above the floor. So now we have set the box. The only thing we can now do is continue the process. We'll create our dense cloud. So let me actually start doing that. And there we go. We have now calculated our dense cloud, and you will see automatically that on the floor we get very little noise, and we actually start, when we create a mesh, all that small noise will automatically disappear. And the model is nice upright for our scan. So let's continue to process this to a mesh, and I'll just also show you how you then can create the texture again without actually removing the projection. So let's create a mesh out of this. And there you go, we now actually have a mesh. And as you can see, we have a nice clean floor and our very nice level with the ground. Completely automated and that kind of stuff. So normally, of course, what we do is we would export this model to an OBJ. We would clean up this model, we clean up the space, we smoothen out the areas where there was no projection. And then we would, in here, we would re-import back the model to actually generate the texture. So let me just skip that phase and let me just create the texture actually on this model. To actually now create the texture again, the only thing that we need to do is again, we'll need to change the processes that we need to take the images. Today we're still now using the images with the projection, and we want to swap this back again to the images without the projection. So again, simple mouse click, right mouse click, we'll change the path, and we'll change to the doll without the projection, and we'll apply this to all the cameras. There you go. Now you will see we're back at an image set without the projection. And now, of course, if we actually on this model create our texture, it will actually create the texture of the photos without any projection. There you go, it has created texture, and if we now, of course, see, we'll get to see the model. And there is, of course, no projection on our as we took the image set without any form of projection. Now, of course, this still needs cleaning up from a model perspective, and keep in mind we actually projected the texture now on a model that really was not properly cleaned. So in the end, all you need for this to have this work is, of course, you need the script and you need the simple layout of the marker. So I'll share the PDF with you that I've created that you can print out. This PDF document specifically designed for A1 format, which I know in Europe is a very standard poster format. You can get this printed out very easily anywhere. It has the 70 centimeter distance in the width, and it has the 40 centimeter distance in the width, in the depth. And I just created a nice QR code, something pretty on the mat to look at, which links actually to my website. It just helps the cameras a little bit to do some extra calibration and alignment. But of course, you can stick anything that you want in there. If anyone outside of Europe wants to have this in a different format, please let me know if you don't know how to make this yourself, and I'll actually add another document to that. So that's it from me. As I said, very easy model to actually create an automated process to take your model, process that, and create an automatic bounding box that is leveled with the ground to have your coordinate systems upright. So especially when you start wanting to do this workflow where you want to scan towards a game and auto-rig this with Mixamo, it's an ideal method. But also just in general, if you want to clean up your models and very easily cut out the floor, this model will allow you to help as well. So I'll share the poster and the script on my website on www.pi3dscan.com. Thank you for watching, and good luck with your 3D scanning.